Hello and welcome to another one of D's ADD videos. Today we're going to look at a couple examples of relative extrema problems. In the first problem, we have to notice that there's a denominator there, and in that denominator we have to account for the fact that there could be some vertical asymptotes. It's not going to be a removable discontinuity because there's nothing in the numerator to cancel if I were to take the limit. So what I'm going to do is I'm going to set the denominator not equal to 0 because it can't equal 0 in the bottom. And if I were to factor that, I would get x plus 2, x minus 2. So in this case, x cannot equal 2 if you individually set them equal to 0, or cannot equal negative 2. Alright? So these are critical numbers. Notice I did not say critical points because they don't exist. They're imaginary boundaries. And you can't have a max or min with these guys, but your slope can increase or decrease on either side of the asymptote, right? Or it can decrease and decrease on either side. It can do that. Or one can go up and the other one can go down. Doesn't matter. But either way it can change the slope of the tangent line. So let's take the derivative. In this case, let's bring it up, rewrite it. Don't need the quotient rule. Chain rule is much easier, less work. Still f of x because I didn't derive it. Now I derive it. I bring down the exponent, multiply, and get a negative 4. X squared minus 4 times a raised to negative 2 times the derivative of the inside, which is 2x. Derivative of the 4 is 0. If that was too fast for you, you need to go back and review your chain rule. Watch the video. Practice, practice, practice as always, right? And then that's going to be squared. If I set the numerator equal to 0, I'm going to get x equals 0 if I divide both sides by negative 8. So now I have to do a number line, and I'm going to plot my one critical point of 0. This is the only one that can be a max or a min. Okay. The other two are what? They are your vertical asymptotes at negative 2. We still want to see the behavior on either side. So the first one, or test point I'm going to plug in, is a negative 3. Where do I plug it into? The first derivative. Now note that this first derivative denominator has the exponent of 2. That means that the denominator is always going to be greater than 0 or always positive. You see that? Because when you square something, whether it's positive or negative, the answer is always positive. So positive. So I really only need the numerator to plug in. So negative 3 times negative 8 is a positive number. So I put a big old plus sign, or you can draw an arrow going up, whatever makes you happy. Okay. Now I plug in a negative 1. Excuse me. Again, only to the bottom or the top part do I need to plug in. So it increases up until I get to the 0. And then once I get to the 0, if I plug in a positive 1 into here, negative 8 times 1 is is negative, sorry. Too many videos back to back. And then I plug in a number like 3. 3 times negative 8 is negative. I don't care about the actual value, but I do care that it's decreasing. Alright, so that's my general trend that I have. So if I were asked for increasing and decreasing interval notation, it's increasing from negative infinity to negative 2, always a parentheses with negative infinity. Negative 2 gets a parentheses because it's an asymptote. And also from negative 2 to 0. And then decreasing would be from 0 to 2 and 2 to infinity. You might ask, why does 0 not get a bracket? Well, 0 is a critical point. We set the derivative equal to 0. The derivative is the slope of the tangent line, and a 0 slope is a flat line. It's not increasing or decreasing. Alright, so let's make our one conclusion. We can say that 0, comma, if I plug in my function to get the y value, I get 4 over 0 squared minus 4, which is a negative 1. So 0 comma negative 1 is a relative maximum. Alright, if you run out of time on your test and you want to write down 0 f of 0, they should accept that. You're telling your grader, okay, I know I should have put a y value in Extrema as an x and a y, but I don't have time to do it, so these would be the key things in the boxes in orange that they would ask you for from this problem. Okay, make sure you practice these types of problems. I'm going to do one more. This is the special case scenario. Make sure you check out the video associated with that one. I don't want to make these videos too long because of the attention span of your modern students is really short. So practice, practice, practice. Thank you and have a nice day.